red giant star located on the outskirts of our galaxy, is emitting alarming signals across the universe. Utilizing the James Webb Space Telescope, astronomers have discovered something deeply troubling about this massive celestial body. Renowned astrophysicist Brian Cox has issued a serious warning, raising the question: are we on the verge of witnessing a catastrophic supernova explosion that could permanently alter our night sky? Let's delve into this. In the vast expanse of the cosmos, where stars are born, live, and die in spectacular fashion, one star has recently drawn the attention and concern of both astronomers and the public. This star is Betelgeuse, a red supergiant of immense size and age, prominently located in the Orion constellation. Its reddish hue and fluctuating brightness have long fascinated observers, but recent developments have heightened interest in this celestial giant. As we explore Betelgeuse nature, we find ourselves on the brink of a potentially monumental event in its life cycle. But what do these changes signify? Are we about to witness a cosmic spectacle of unimaginable scale? Betelgeuse, approximately 764 times larger than our Sun, is a stellar behemoth. Its colossal size is almost beyond human comprehension. Imagine a star so vast that if it replaced our Sun, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars in its stellar embrace. This immense size not only highlights Betelgeuse's physical attributes but also indicates its stage in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight of its existence, a phase marked by expansion and cooling after a lifetime of fusing hydrogen into helium in its core. Betelgeuse is believed to be around 8 to 8.5 million years old, relatively young in human terms but ancient in the context of stellar lifetimes. Its current red supergiant phase is the culmination of millions of years of stellar evolution, a period characterized by dramatic changes and processes that have transformed it from a hot blue star to the red giant we see today. The life cycle of stars like Betelgeuse is a tale of transformation driven by the relentless forces of nuclear fusion and gravity. Betelgeuse's reddish hue is a hallmark of its current stage, resulting from its relatively cooler surface temperature compared to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's cooler surface registers around 3,500 Kelvin, allowing it to emit light at wavelengths that give it a red appearance. This color provides clues about the star's physical condition and the processes occurring within its vast gaseous expanse. Adding to Betelgeuse's mystique is its historical color change. Ancient Roman and Chinese writings suggest that around 2,000 years ago, Betelgeuse was yellow. It wasn't until the 9th century that Arabic scholars described it as red. This color shift over human history offers a clue to the star's evolutionary path. Betelgeuse's variable brightness is another intriguing aspect. It is a semi-regular variable star, meaning its light periodically waxes and wanes, a characteristic dance of luminosity that has fascinated astronomers and sky watchers for centuries. Typically, Betelgeuse undergoes a 400-day cycle, along with a longer cycle stretching about 5 years, documented as far back as 1836 by Sir John Herschel and possibly earlier in Aboriginal oral traditions. What makes Betelgeuse truly enigmatic is not just its changing brightness but its irregularity. Unlike many stars that follow a predictable pattern, Betelgeuse occasionally deviates from its rhythmic dimming and brightening, hinting at complex and less understood processes within its colossal form. In a recent groundbreaking revelation, Betelgeuse captured global attention with an unexpected and dramatic change in its appearance, known as the Great Dimming. In late 2019, Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the Orion constellation, began to mysteriously dim. The dimming was so pronounced that by February 2020, Betelgeuse, normally visible to the naked eye even in light-polluted areas, became markedly fainter, a change noticeable even to amateur observers. However, monitoring Betelgeuse activities presents a challenge due to the time paradox. When we observe a star like Betelgeuse, we are seeing it as it was in the past, not as it exists in the present. Given Betelgeuse's distance of approximately 725 light-years, the light we perceive today left the star nearly 7 centuries ago. This time lag makes it difficult to predict and monitor sudden changes in the star's behavior, as we are essentially peering into its past. The Great Dimming event was closely monitored by Andrea Dupree, associate director of the Center for Astrophysics at Harvard and Smithsonian, and her team. They used the Hubble Space Telescope to analyze Betelgeuse as part of a 3-year study to monitor variations in the star's outer atmosphere. These observations provided unique insights into the dynamics of a variable star like Betelgeuse, which regularly expands and contracts, causing fluctuations in brightness. Hubble's sensitivity to ultraviolet light allowed researchers to probe the layers above the star's surface, heated partly by the star's turbulent convection cells. Further analysis of Hubble's spectra taken throughout 2019 and 2020 helped measure the movement of material in Betelgeuse's outer atmosphere. The spectra focused on magnesium-2 lines, indicative of the star's atmospheric conditions, showing material moving at speeds of about 200,000 miles per hour from the star's surface into its outer atmosphere. This hot, dense material eventually extended millions of miles from Betelgeuse and was the precursor to the dust cloud that led to the star's dimming. Dupree and her team estimated that about twice the normal amount of material from Betelgeuse's southern hemisphere was lost over the 3 months of the outburst. This mass loss was significant, especially considering that Betelgeuse, like all stars, continuously loses mass, albeit at a rate far greater than that of our Sun. The scale of this mass ejection and the subsequent dimming sparked discussions among astronomers about whether this event could be a precursor to a supernova explosion. Betelgeuse's proximity, about 725 light-years from Earth, adds to the intrigue, as any such explosion would be visible from Earth and provide a rare opportunity to observe a supernova up close. Yet, the question remains, what does this dimming event portend for Betelgeuse's future? Is it an indicator of an impending supernova or simply a unique episode in the star's long and complex life? Several theories were proposed to explain this sudden change. One prevalent theory suggested a phase in the supernova explosion process, a hypothesis that gained traction due to the common belief that Betelgeuse is nearing the end of its life. Another popular theory implicated dust, possibly from the star itself, obscuring our view. Betelgeuse, like other red supergiants, is known to shed material, and it was thought that this material could form a dust cloud dense enough to dim the star's light from our perspective. A third explanation considered changes in the star's photosphere, the visible surface layer, which could affect its apparent brightness. In-depth analysis using various observational methods helped unravel this mystery. Spectroscopic studies indicated a drop in Betelgeuse's effective temperature, suggesting that the dimming could be due to a large dark spot on the star's surface. This theory was supported by the observation that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming, pointing to significant changes on its surface. Ultimately, the key to understanding this unusual phenomenon came from the Hubble Space Telescope. Hubble's observations revealed that the dimming of Betelgeuse was most likely caused by a significant ejection of hot material into space. This material formed a dust cloud that obscured a portion of the star's surface, effectively reducing the amount of light reaching us from Betelgeuse. The dust cloud was believed to have formed from superhot plasma, which erupted from a large convection cell on the star's surface and then moved through its hot atmosphere to the colder outer layers. As it cooled, it formed